Hi, I'm Brandt Underwood. I'm the agronomist with NRCS. I service the southern high plains and panhandle of Texas. Today, we have some tabletop soils demonstrations. The first demonstration we have is the slake test. This is a soil aggregate stability test. What we're going to do is take two separate clods of soil, the same soil. One is no-till, one is conventionally tilled. Now, if you look at these pedons, the no-till is much darker because of the higher organic matter. The conventionally tilled soil is much lighter and has lesser structure. When we put these two clods into the water, the no-till clod will stay together because it has good structure and good aggregate stability. This clod will dissolve like we've all seen. Now let's do our aggregate stability test, or it's also known as the slake test, and see what happens. As we can see, our slake test has just finished running. Our conventionally tilled soil is completely slaked off, and our no-till soil is at a stable point where there's still an aggregate. What is an aggregate? A soil aggregate is basically a clod of what most people would call dirt. Why we use this test is to show the difference between the conventionally tilled soil and no-till soil. The no-till soil with crop residues left on the soil surface has soil structure and the aggregate stability. This is created by the living glues exuded by the soil microbiology. This principle is the same whether we're in a 1,000-acre farm or your backyard garden. Now, we're going to show you what aggregate stability really means. When we use this tabletop model of the rainfall simulator, what we're going to show is that soils with well-developed aggregates, such as our no-till, have much faster infiltration rates than our conventional till because they have a well-developed structure with a lot of pore space, and the residues are on the soil surface to lessen the impact of the rainfall so it can get in faster. Our conventionally tilled soils are collapsed and will have a tendency to run off. Both measuring cups contain 24 ounces of water. Now let's make it rain. As we can see, our conventionally tilled soil almost immediately starts to run off. As we look at our no-till field with crop residues and a living cover crop on the soil surface, it's infiltrating. We've run our demonstration. Let's see how much water we've actually ran off of our field. We have 16 ounces in our measuring cup. We started with 24. Over half ran off the conventionally tilled field. So for farmers of the southern high plains and panhandle of Texas, this means we are able to catch almost double the amount of rainfall in a soil health system where we are using no-till with crop residues on the soil surface, cover crops, and good management. We use simple and fun demonstrations like this to inform our farmers of their land's capability. These demonstrations also show you how an intense rainfall event can cause water erosion. And in that erosion, we lose the most valuable part of the topsoil, which has our fertilizers and chemicals that we've applied. In the no-till system, with soil health principles applied, we have taken all that rainfall and infiltrated it and harvested it. And whether this event was rainfall or irrigation, we've done a much more efficient job of harvesting water in the no-till system. We also use these simple demonstrations to inform youth and teach consumers about what the American farmer is doing with their management.